Welcome for today's class. In this class, we will discuss about the addressing modes of 8086 processor. 8086 processor is being using 8 different addressing modes for accessing the data. Immediate addressing mode. First one is immediate addressing mode. So, the name itself is saying the required data is being available within the instruction itself, that is the immediate addressing mode. For example, move AX comma 0005H. So, in this case the A0005H is the data required. So, that will be copied into AX register. So, in that AH will get 00H and AL will get 05H. So, 00 is MSB and 05 is LSB. So, the MSB byte is loaded into AH register and LSB byte is loaded into AL register, that is immediate addressing mode. And the next second one is direct addressing mode. So, in the direct addressing mode, the memory address is specified where the operand is available. So, the memory address is specified in the instruction where the operand is available. So, here 5000 is the memory address, for example. So, from 5000 location, the data present in the 5000 location will be copied into AH. For example, if this is the memory and say for example, this is location 5000 and say this is location 5001. Say in 5000, say example the data is 35 and 5001 is say 25. Okay. And with this direct addressing mode, location 5000 data is being copied into AL and 5001 location data is copied into AH, that is AH will get 25 and AL will get 35. So, the data present in 5000 location is copied into AL and data present in 5001 location is copied into AH. So, that is direct addressing method. The third one is register addressing mode. In the register addressing mode, the operands are available in the registers. So, in this particular move AX BX comma AX, for example, the register addressing mode instruction is say move BX comma AX. In this case, before instruction, for example, AX is having say 1000 and say BX is having say 2500H, for example. Now, after executing this instruction move BX comma AX, then in this case BX will have 1000. So, before the instruction is executed, AX is having 1000H and BX is having 2500H. After execution, so BX register will be overwritten with the contents of AX and AX content will not be disturbed. So, they will remain as it is. So, here the source content remains as it is, will not be disturbed, whereas the destination will be updated with the source information, that is the register addressing mode. Next is indirect addressing mode. So, in indirect addressing mode, the address of the memory location is being specified in the register. So, for example, the instruction is move AX comma BX. So, here the register BX will have the memory address where the operand is available. So, that memory address is not specified directly. Now, it is specified through a register. Now, the register BX is acting as a pointer for the operand. So, for example, so before the instruction, suppose BX is having say 5000, then after executing this particular instruction, so BX is pointing 5000, that is say for example, this particular 5000 location say 35 and 5001 is 25. Now, AX will have, after the execution of the instruction, AX will have 25 35. So, AL will have 35 and AH will have 25. That is how the content will be copied into the destination place. So, here the destination is AX, source is BX, that is as a pointer. This is first 4 set of addressing modes. The next addressing mode is indexed addressing mode. So, here the index register will be used as the pointer. Here the index register will be used as the pointer. So, the whatever address is loaded in, say for example, move AX comma SI. So, now SI is acting as, that is source index register is acting as the pointer. Now, for this generally whether it is indirect or direct, now the effective address will be calculated. So, effective address is 10H into contents of the data segment register plus the content of the source index register will give the effective address. So, whether it is indirect addressing mode or direct addressing mode, any of these addressing modes, effective address can be calculated like this. So, even the previous case, for example, in this direct addressing mode, so here also the effective address is calculated as 10 into DS data segment plus 5000. Here the direct addressing is being given as 5000, that will give the 20-bit physical address. So, from there the content will be loaded into the AX register. So, in case of indirect also, here the effective address is calculated as 10H into DS plus the contents of BX register. So, that will give us the effective address from where the content will be loaded into the AX register. This is how the effective address is being calculated. So, irrespective of the addressing mode, the effective address is being calculated like this. Now, after calculating the effective address, now content of the location specified by the effective address will be copied into AX. Okay. Suppose if DI is, see, if DS is having say 1000 and say SI is having say 5000, then effective address is going to be 10 into 1000 plus 5000. So, 10,000 plus 5,000, effective address is going to be 15,000 H. Okay. Effective address is going to be 15,000 H. Now, AL will get the content from 15,000 location and AH will get the content from 15,001. So, this is how the effective address is being calculated and the operand will be loaded from the address into the specified destination. So, that is indexed addressing. Next, register relative addressing mode. Here also the effective address is being calculated relative. So, that means displacement is being specified with this. So, here the effective address is equal to so 10H into DS plus BX register content plus 50H. So, this will give the effective address. So, from here the content will be copied into AX, that means, so from this address into AL and next address to AH. So, this is how the relative addressing mode. Base index addressing mode, the next addressing mode is base indexed addressing mode. So, here a base register and index register are specified in the instruction as a source or it can be a destination also. Here in this example, move AX comma BX SI. So, here BX and SI are the base and index registers pointing the source. So, input operand, so which is going to be copied into AX register. So, here also the effective address is being calculated as 10H into DS plus content of the BX register plus content of the SI register. So, that will give the effective address. So, from there the content will be copied into AX. Next addressing is relative base indexed addressing mode. So, here the relative displacement, index register, base register are being specified in this addressing mode. So, here the effective address is being calculated as 10H into DS plus content of BX plus content of SI plus displacement, which is specified as a constant 50H. So, which will give the effective address. From this location the information will be copied into AX register. So, first location into AL and the next location into AH. This is how 8 different addressing modes that are being used for accessing the operand for processing of anything. And the next set what we are going to discuss is the addressing modes for control transfer. Here the addressing mode is for the next instruction. So, previous 8 addressing modes that what we have seen are for accessing the operand for processing. Now, these 4 addressing modes, so the next 4 addressing mode that we are going to discuss are for fetching the next instruction when it is a jump. So, when program is going to be deviated from the current sequence to some other sequence, then the address will be calculated for the next instruction. That address calculation is being done one of these 4 methods. So, inter-segment direct, inter-segment indirect, intra-segment direct and intra-segment indirect. So, that there are intra-segment and inter-segment. So, in case of intra-segment, present sequence and the next sequence, both set of instructions will be present in the same segment. Then the deviation from the current sequence to next sequence within the same segment comes under the intra-segment. Whereas, if the current sequence is in one segment and the next sequence of a set of instructions are in other segment, then the deviation between these two comes under the inter-segment. So, here the inter-segment and intra-segment we have both direct and indirect. First, we will see the inter-segment direct addressing mode. So, in case of inter-segment direct addressing mode, so the effective address will be see. So, previously whatever may be the case, now suppose previously CS code segment is say 2000 and instruction pointer say for example 2500. So, in this case, so address of the next, suppose if the CS code segment register is holding the value 2000 and instruction point is holding the value 2500. So, the effective address for the next instruction is 10H into CS plus IP. So, which is 20,000 plus 2500. So, which is 22,500 H, that is the address of the next instruction if they. So, this is the present sequence. Now, suppose we have the instruction jump 5000 and 2000. Now, the next instruction will be fetched from this, that is. So, CS will be loaded after this instruction, CS is loaded with 5000 and IP is loaded with 2000. So, as a result the effective address for the next instruction is 10H into CS plus IP. So, here it is 50,000, 5000 into 10, that is 50,000 plus 2000. So, next instruction will be fetched from 52,000 H onwards. So, instead of fetching the next instruction 22,500, next instruction will be fetched from 52,000. So, they are from different segments, that is the inter-segment direct addressing mode. The second is inter-segment indirect. So, in case of inter-segment indirect, so now the memory address is being specified. That means, now the 4 locations of the memory address 2000 onwards will be fetched and that will be loaded into both code segment and instruction pointer registers, which will give the address of the next instruction to be fetched from a different segment. So, here what we are going to do is, see, so for location 2000 and 2001 is copied into instruction pointer, and location 2002 and 2003 is copied into code segment register. Okay. So, in 2000 will be instruction pointer lower byte, and 2001 content will be the instruction pointer higher byte, and 2002 will be the code segment register lower byte, and 2002 content will be code segment higher byte. So, that is how. So, from this particular location, so 4 different a content from 4 different locations will be copied into both IP and CS, which will give the effective address of next instruction. Okay. So, the effective address is calculated as 10H into CS plus IP. The same procedure is being used for calculating the effective address. So, that is how both segment register and instruction pointer will be updated with the new addresses, and the next instruction will be fetched from that new addresses computed by both CS and IP, that is inter-segment. So, the next addressing modes are intra-segment. So, again in intra-segment direct and indirect. So, in case of intra-segment means now the same segment. So, the next set of instructions will be executed from the same segment. So, current sequence is at one place of this segment, and the next sequence will be in some other place of the same segment. So, as a result, now the code segment register need not be updated. So, whatever value is present in the code segment, it remains same. So, that is not going to be updated, it is a constant. Whereas, only the instruction point for these two methods, only instruction pointer is being updated with a new sequence. Address for new sequence is updated only in the instruction pointer, the code segmenter will remain as it is. So, again in this intra-segment direct addressing mode, jump short label. So, here what is being done is, so the effective address for the next instruction is 10H into CS, which is constant, will not be changed, and contents of the IP, contents of instruction pointer. But now instruction pointer is being calculated, the updated with current position of the IP plus whatever address is being specified at this point, that is short label. Short label, this value is being added with the present contents of the instruction pointer to get the updated value of instruction pointer. Then from that updated value, the next instruction is being fetched. Okay. So, here the short label can be, so signed number 1 byte, short means 1 byte. So, the value specified at this point is a 1 byte value, which is a signed 2's complement method. 2's complement number, that is it is a signed number, that means, so the content of the instruction pointer is IP plus or minus this label, whatever short label we have, that is being included as plus or minus. So, that means, so the next instruction will be either from the current position, either ahead or behind. So, likewise is being calculated the short label, and that is about the intra-segment direct addressing mode. And finally, intra-segment indirect addressing mode. In case of intra-segment indirect addressing mode, so the value of now register here BX in this particular example, jump BX, here the BX register is acting as the pointer. The content of the BX will be loaded into the instruction pointer for calculating the next effective address. So, here the content of BX will be giving the offset address of next instruction, which will be copied into an instruction pointer for calculating the next address. So, that is IP is going to get the contents of BX register. Now, the effective address is 10H into CS plus instruction pointer, that will be the effective address for the next instruction. So, this is how the data and the instructions are being fetched with various addressing modes. So, 8 different addressing modes that we have seen for the operand purpose or data part, and 4 addressing modes we have seen for the getting the next instruction. So, today I will stop at this point. We will continue with some other topic in the next class. Thank you all.